This is the narrated PowerPoint on the quantitative testing chapter in Hughes and Hayhoe. The authors spend quite a bit of the chapter talking about how studies are set up, quantitative studies, and especially statistical interpretations, and they take you through step by step how to use Excel to do different types of statistical applications. And what I'm thinking that you'll do this week is, with that data that we crunch, or we create to crunch, that you'll crunch it and come up with some analysis and some conclusions about the instructions that you've been following. So, what is a dependent variable? This is basically what you're testing. If, for example, you set up an experiment where you had 3 groups of children, and one group you exposed to a lot of violence on television and video that they might watch during a week. And then you had another group that didn't watch anything, that just watched Care Bears and SpongeBob SquarePants and things like that. And then you had another group that watched what is considered to be a normal amount of violence on TV or in videos. And if you put them on the playground, the dependent variable would be what you're trying to measure, which in this case might be if the children who are watching more violent programming are beating up the Care Bear kids because they're watching a program with no violence. And so the independent variable would be other things that are present that you're not really testing, like gender. Are boys more likely to be violent than girls? Or the ages of the children, things like that just exist that you might account for in your study, but they're not what you're actually testing. And then we have this idea of a null hypothesis. We were just talking about, we might hypothesize that the children who watch more violent programming are going to be more violent on the playground, and then we would see whether that's true or not. So we have 2 different outcomes there. And then there is a third outcome, which would be, we refer to as the null hypothesis, that there would be no significant difference between the groups, or perhaps just with the children that are watching more violent programming. So the chapter talks about various ways of manipulating data. One, of course, is the mean, which as students you're all familiar with, adding items up and dividing by the number of cases to get the average. I'm sure it's something you all know how to do. The median is also something that's an interesting way to approach data, because it is the one in the middle, and it's less susceptible to outliers. To determine it, if you have an even number of cases, it's the average of the 2 middle terms. If you have an odd number of cases, it's the actual middle number. And then they talk about the standard deviation, which is, this is how the averages, or the amount of space between the data averages, or the extent of deviation from the mean. There's another way of expressing it. So here's how these might look. Okay, so here's a set of data that we have. Let's say that's a test that I gave, and I'm scanning down it, and I see 1, 0, for example. That's not good. And we know, well, that's going to pull everything down slightly. And if we get the average for this set of scores, it's a 69. Well, that's not good. That's below average. That's a D+, right? just scanning the scores again, we see some A's in there. So what's up with this group? Well, if we set it up so that we are looking for the median, now one of the first things we have to do is to set it up so that they're arranged from highest to lowest. It's not necessary with the averages, but it is to look at the median. And so when we look at this, we can say, well, it's not just the 0 that's pulling these down. There's two 25s and a 33. And if this were strictly a multiple choice test, we could probably say that the 33 and the 25 probably didn't study the material at all and they just guessed. As a matter of fact, if a multiple choice test is balanced correctly, you should be able to go through it and just give it the same answer for each one, like answer A for every single one, and you should get 25% of them right, roughly. And if we look at the median for this particular set, it's an even number. So it actually, in this case, it winds up being 77. And so that makes me feel better as a teacher, because this set of scores is just slightly above average. Certainly not the score you probably want on a test, but it doesn't make the test seem as if it were too hard. So. And then, of course, what we could do, we could also just take out these outliers. We could do the average again, and then without the 33, the 225s, and a 0, the scores, and that's still including a couple of D scores, but the average goes up to a 79. And I'll tell you, without showing you, if you just take out the 0, it goes up to a 71. So that gets us in the low C range. So, again, these outliers are pulling things down. And I think the assumption we can make is that the test wasn't too hard. The standard deviation I mentioned is the average of the difference between that set of numbers. And with, again, thinking about test scores, if you have one way the standard deviation can be applied would be if you have a set of scores. If a good place for the standard deviation to be, if on a scale of 0 to 100, is somewhere between 10 and 20 would be good. If it was below 10, that would indicate that the scores were clustered together too closely, and so that would probably indicate that the test was too hard. If it was over 20, that would mean that the test scores were too widely scattered, and that might indicate that the test was too difficult, according to the standard deviation. Another value one is the correlation coefficient, and there you're looking for the relationship between two variables, and this is actually one that's the relationship between birth weight and the length of a baby. And you can see generally the way that works is that it comes out to be a strong positive, and you can use a scatter plot like this. I mean, this is the way that it actually looks in order to see how it works out. But if it were weak, as it was in number 2, then you wouldn't see that type of linearity that you have in number 1. And then if there was no correlation at all, then it starts, number 2, I'm sorry, was a weak positive. And then if there's no correlation at all, then you would see in number 3, everything's kind of spread out. And there's no linearity at all to the data. And then again, if you had a negative correlation, which you can certainly get, then you would see it would be going leaning the other way. So this is set up on a graph. Okay, the book gets into talking about probability and ANOVA tests and things like that. And again, if you're going to do a master's thesis and you're going to do any type of a quantitative study, you really need to have a statistics course, and you also need a statistics professor on your committee. But I'm not. That's as far as I'm going to go, just to talk about some of these general types interpretations. Um, T-tests and probability are good for showing the how um, reliable the your data actually is, but it gets a lot more complicated. I'm not, and this is not a statistics course, and I'm not a math teacher, so I'm not going to go any farther with that. But questions? I'll see you online.